So let's get to the bottom of this, okay? First, I'm going to graph some of these things. If I graph sine of x, it looks like this. Now, I want to talk about a few things about domain and range of this. Okay, so I'm gonna copy this thingy and paste this thing to the notes. Now, as you know, these things will stay here for, let's say, a week at a time. And after that, I will start deleting it, okay? Because more official, organized notes is in the Dropbox. Okay, let's talk about the domain and range of these things. The domain is all real, infinity to infinity, and range is 1 to -1, right? More importantly, see, this is not exactly 3, it's right here, and we know that's pi. You know what I'm saying? 3.14, so it goes slightly over 3. And then this, of course, is 2 pi. And this is negative pi, and this is negative 2 pi. How's that? Okay, that worked out. Now, and then, of course, this being pi over 2, 3 pi over 2, and so on. Let's talk about the quadrants. I'm not talking about quadrant 1, 2, 3, 4 in this graph. No, 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 no. God, forget this, okay? I'm not talking about that, and when it comes to inverse trig functions, what I'm going to talk about is this. Quadrant 1 is from 0 to pi over 2, isn't it? That corresponds to here, that much, quadrant 1. You know what I'm saying? 0 to pi over 2. And then, is this quadrant 2 then? From pi over 2 to pi. You get it? And this is quadrant 3. And this is quadrant 4. Did that make sense to you? And then, of course, here, somebody please use a microphone. Tell me what quadrant it is from. Where's my mouse? My mouse disappeared. Where's my pointer? Huh. This is weird. Am I out of battery? Oh yeah, here. Somebody tell me what quadrant it is from here to here. It's not a trick question.
1.
From 2 pi to
1.
That's 1. And then quadrant 2, it repeats forever now, doesn't it? You guys getting what I mean by quadrant? It's not 1, 2, 3, 4. Now somebody tell me what quadrant this is then.
4.
That's 4, right? And this is 3, and then this thing repeats forever. You know what I mean by quadrant number? That corresponds to the unit circle, right? Which has been unwrapped on x-axis. That's crucial in understanding the domain and range of this thing, all right? Okay, now, we go here, then we will create inverse functions. Then by finding the inverse, of course, we switch x and y, right? So we switch x and y, and it looks like this. Wow, I know, spectacular. Amazing, isn't it? I amaze myself sometimes. Okay, I'm gonna copy this thing. Okay, and go back to my notes here. Okay, so we have this. Okay, once again, just to make sure there's no confusion over this, I want to talk about the quadrants one more time, okay? So, you see this is pi over 2. This is pi, and this is 3 pi over 2. Negative pi over 2, negative pi, and negative 3 pi over 2. So, do you see this is quadrant? I'm going to do it with a different color now. Do you see this is quadrant 1, and this is quadrant 2, and then quadrant 3, and so on forever? And this side right here is quadrant 4, and 3, 2. Are we good so far? You know what I mean by quadrants. This is very, very crucial when we do this. Okay, then having said that, there's only one problem with this. What's the problem? What's the problem? This looks nice. That's an inverse. So what's the problem?
It's not a function.
It's not a function, right? It fails the vertical line test infinitely many times, eh? So, and then of course the question is, what's the big deal about function? Why does it have to be a function? Why does an inverse have to be a function is the question. Did you ever, yeah, that you accepted it. But why does an inverse have to be a function? What's wrong with the inverse relation? Oh, in fact, in the olden days when I was in high school, this was called the inverse. And I'm gonna, after I introduce what the inverse function looks like, I'm going to tell you the difference and then clear out some of the confusions. But in a nutshell, this is a modern thing. Like modern textbooks, they said, oh, inverse needs to be a function. We're like, why? One of the reason is, well, unless it's a function, you cannot program the computer, right? If you type in inverse sine of 1/2, there's only one answer, pi over 6. You get it? Computer does not know how to do pi over 6 plus 2k pi or by pi over 6 plus 2k pi. You know what I'm saying? So there's a problem. So some modern days where a computer is everything, yeah, people want this to be a function. So let's say this is a mathematics convention. For the first time in history of math, we are going to limit the range of this thing to make it a function, and you're my fellow mathematicians, okay? We have to cut this thing out in order to be one-to-one. So does it make sense that we should cut? I know, I amaze myself sometimes. Here, and then define this to be an inverse sine function. That makes sense to you? Yeah, let's make a copy of this. So if I make a copy of this and go back, and then I'm gonna put it right here below. So this is an inverse function. Okay, I'm gonna write f of x. I wanted to prove, no, it doesn't let me change the color. Red is okay, right? F of x is equal to inverse sine. Now I'm using a function notation, right? Let's talk about the domain and range of this thing. Domain, of course, is from -1 right here to +1 right here, right? And then range, of course, is from here, which is -pi/2 to there, +pi/2. That much is easy. Let's talk about the quadrants, because some students always say, oh, isn't that quadrant 1 and 3? No, we are not talking about quadrant 1, 2, 3, 4. You see, we are talking about these quadrants here, okay? In other words, you just look at this, and what quadrant is it? Well, pi/2, -pi/2. Here, you get it? So this is, I'm gonna write it here, quadrant 1 and quadrant 4 to avoid the confusion. How about that? Did that make sense to you? I'm going to clarify some things. Did you know that different textbooks have a different definition? What? I thought definitions were gospel. It's like Bible. That's what it means. How can you have different definitions, right? See, if you listen to this bunch of middle school boys arguing about something, it's always about the definition, isn't it? Pizza is a vegetable. No, it's not. Yeah, it is. No, it's not. Let's ask the teacher. Remember that? Or if you listen to high school debate team, anybody member of high school debate team? I'm sorry, but it's true. You know, they love to argue about the definition. What's the meaning of this word? What is not? What is this? And of course, Congress, right? Politicians. I'm lumping those three at the same level, and because they're just exactly at this level of annoying middle school boys. You know, they love to talk about this definition. What does it mean? What does it? Oh yeah, if you haven't decided whether you are for me or not, then you ain't black. Remember that, Joe Biden? So that he wants to define what black means, right? It's like, oh, what? I thought that has to be genetics. No, I guess not. Huh? Liberals. Right? However, if you ask philosophers, because these three groups have only one objective: win at all costs. They want to win the argument, and they will say the stuff they don't believe in, and they are not willing to defend deep down, but they will say it just to win that argument. Is that what high school debate TV is all about? Yeah. But if you ask philosophers, they have a different take. See, philosophers' definitions doesn't matter as much. As long as, let's say, we are discussing about something, we agree on, let's define certain things this way, and then we can still, there's an underlying truth, regardless of what definition is. You know what I'm saying? So definitions are not absolute. They can agree on that. That depends on how you define this. Also, let's define it this way. Then we can still talk about. See, philosophers, their objective is the truth, the logic. So they will not say such a thing they don't believe in or willing to defend. And when they lose the argument, they will concede that point. When somebody presents a logical proof, they will accept it. They don't just say, no, it's not true, like politicians. So when you go to college, different textbooks have different definitions. Oh my God, right? And in case you're unlucky, sometimes your professor has a different definitions and notations from your textbook. And then it's really confusing. When you read and when you listen to the lecture, they are talking about same thing, but with two different notations. That happens too. Okay. I like to clarify some of the things that might have been confusing in the past. Okay. This is an example. If you have a sine, inverse sine of 1/2. Oh no, what am I saying? If you have sine x is equal to 1/2, how were you taught to solve this? You were taught to do this. So x is equal to inverse sine of 1/2, right? And then x is equal to pi over 6 plus 2k pi, or x is equal to 5 pi over 6 plus 2k pi. That much look familiar? Okay, now I have one question. Is that thing, that inverse sine, is this a function or not? The way it is written is not a function, right? This is a relation. Because it's got multiple answers, so it cannot be a function. If you think about it, that means this, right? This is 1/2, and where is, that's a pi over 6, and this is 5 pi over 6, and forever, 2k pi. However, if you plug this into your calculator, it only gives you one answer, and this is it. And this is function, right? Which way is it? That's confusing now, isn't it? I mean, I'm pretty sure some of you were confused, but accepted, and then they learned to distinguish which is which. You know what I'm saying? So let me clarify this. This is the olden days when we, the teachers, were in high school. We were taught this way. And in order to distinguish the two, they actually use capital S. So when we use capital S, this means a function. When we use lowercase s, that means a relation, and that's what this is. You get it? So that's what it used to mean. And then many teachers, since that's how we are taught, we just teach exactly the same way. So when we are talking about this, then it means it's a relation. But when we get to the inverse function section, then we actually drop this thing. And then because the book does not use capital S, so we just still write it, and now this is a function, right? So this is in the olden days. Now I'm going to translate these into today's language. God, I wish I can change the color. No, I can't. So today, this is today's language. That thingy, now instead we write this. And that's exactly what that graph is. You know what I'm saying? And this, of course, now has become, right? That's what this graph is. So what used to be the relation in the olden days with the lowercase s, they just write it like this, just any relationship between x and y. This is modern textbook, your textbook's notation and definition. And then what used to be capital S is now just a regular S inverse sign. And then, of course, you know the arc sign means same thing as inverse sign, right? You get it. Does that clarify a lot of points about domain range, what's a function, and why do we? Yeah. Okay. For me, I would prefer if you don't write this line at all, because I want to be consistent with the notation. When we write inverse sign, it's always a function until you go to college and your textbook goes back on this, right? Until you see another definition. For now, we'll just agree inverse sign has to be a function, which means if you write this line, that means there's only one answer. So let's not write that line. We'll just go from here to here. How about that? Okay. Do you have any questions? Does that clarify everything, all these little things in the back of your mind, you accepted and moved on? Right, okay. Once you accept this, now we can move pretty fast. Let's talk about cosine, okay? So I'm gonna hide this. And then I'm gonna put cosine graph. So this is what cosine looks like, right? Okay, in order to find the inverse, of course, we switch x and y. Okay, now, well, this is not a function again, so we have to limit it, right? So where should we limit this? Well, one might say, well, exactly the same place that we cut this inverse sign, right? You see the problem with this? Still not a function. It still fails the vertical. No, so we cannot use the same restriction. Okay, my fellow mathematicians, this is a mathematics convention. Do you want to take all positive or do you want to take all negative? Which way is it? Which one would you prefer?
Positive.
Positive.
For why? What's wrong with the little negativity? Why does everybody insist on positiveness? Does positive thought really give you a positive result? Really?
The negative sign takes longer to write.
I will forget the negative sign. And
Yeah,
then miss.
Okay, I'm gonna give you one example where the negative rules. Let's learn how to factor. Which was positive, you stare at it. No, forget it. You just write both of them with negative, and then you decide, oh yeah, this is C. Changing negative to positive is so much easier and faster than the other way around. You see the power of negativity? Like, why do we have to think positive? I don't get this in a society. If a positive thought really gives you positive results, really? Like, didn't you all want to be like varsity basketball member or something when you're growing up, when you're young? How's that working out for you, right? Yeah, right, all you nerds and that you're instead of playing varsity basketball, you're here with me together in Calculus BC, right? And if you still have a choice, you still go for varsity basketball, but no. You realized long time ago, you're not that athletic or tall, and all that positive thought ain't gonna make you taller or jump higher or more athletic. So realize, you got it where it counts anyway. It's okay, being smart is better. Let's take calculus. Isn't that why you're here? I mean, don't you want to be prettier and more popular too? How's that working out for you? I know it hurts now, doesn't it? Truth cuts deep. Something about truth is, and get ready, because this will hurt a little bit. It doesn't care what you think. If the truth cares about what you think and then like bends towards the populism, that's not what truth is. That's like against the definition of truth. Truth is still truth. It's still out there, whether you like it or not. If nobody in the world ever agreed, truth doesn't care. You know, a lot of people used to believe that Earth is flat, right? And Galileo was the OD guy who thought, no, Earth is not. Oh, you real? We're gonna execute you. Say Earth is flat. Okay, sure. And then as he was walking out of that court, he said, but it's still round. Okay, Earth is not. Okay, Earth is not rectangle according to a lot of people who believe in flat Earth. Nowadays, they have a disk theory. It's a disk. That explains that the horizon being a little bit curvy because it's a disk. You get it? But truth really. Okay. I digress, because yeah, I'm recording a video, so I screwed up second period because I went off of this and all. Okay, all that positive thought does not necessarily give you positive results. Think of Titanic. If when Titanic was taking in a lot of water, remember they had enough lifeboats to save everybody. That's kind of a regulation. Any vessel that's going out to the ocean, you have to have enough lifeboats for everybody in case that thing goes down. No, instead of trying to evacuate or abandon the ship, what did they do? The ship of this size cannot possibly sink now, can it? Let's just all think positive. They all died. Few people who decided, okay, this ship cannot be saved, let's go for the lifeboat, are the only ones who survive. Like, why are you so pessimist? No, I'm not a pessimist. I know I can be positive too. I know I'm really awesome. I'm amazing. Sometimes I amaze myself. See how positive I am? It's just the rest of the world. They are not so intelligent. Let's just put it that way. You know what I'm saying? It's realistic thinking. Realize your weakness and strengths and just deal with it. You get it? So all that positive thought doesn't really, okay, whatever, back to here. However, without consulting with the god of mathematics, a long time ago, these mathematicians have decided to go with positive. Yeah, you happy now? So let's make a copy of this. Okay, and go to notes. So let's put it here. Okay, now. So if we call this f of x is inverse cosine of x function, let's talk about the domain. Domain is still -1 to +1a, but the range now, see, this is 1 and -1 is from 0, and that's pi, eh? So this is from 0 to pi. Now what quadrant is it? We are not, once again, we are talking about this quadrant, right? On a unit circle, your range. 0 to pi is quadrant 1 and 2 is what we mean, right? It's like there. You know what I'm saying? Okay. Okay, and now we are ready to talk about tangent. So let's hide this and graph tangent. I said graph tangent. Tangent x, of course, looks like this, right? Somebody tell me the location of these vertical asymptotes, which is not showing. The first one right here is at. This is when you say with you're using your microphone. God.
Pi/2.
Thank you. Was that so hard? And this one, somebody else?
-pi/2.
Oh, yeah, you meant that one. Okay, okay. 3pi/2 and pi/2 plus n pi, right? Or k pi. Alrighty. So now we're gonna rotate this around, switching x and y. So we have this, right? Well, should we just take, is it logical to take the middle piece? You know what I'm saying? Yeah, let's take the middle piece. I mean, I can reduce, make it smaller, but I can just copy. No, that's not working. Hold on. I have to take that middle piece. Say, yeah, that'll work now. Okay, like that. So we take that middle piece and put it right there. So this is what inverse tangent thingy looks like. Now be careful, the asymptotes are part of the graph, right? Of course it exists out here this way too, but that's a useless one, isn't it? So we typically throw it one side, and that location is pi over 2, and the other one is at negative pi over 2a. So this function f of x is equal to inverse tangent x. Let's talk about the domain and range, eh? Domain of this thing, of course, is everything, right? Infinity to infinity. And then range of this thing, now we have to exclude the asymptotes. And quadrant 1 and quadrant 4. That makes sense to you? So on a unit circle, it's still that much, which is pi over 2 here and negative pi over 2. Good. Okay, we are moving along and making, wow, we're still running against time. God, I'm not going to get to your homework questions, huh? Hopefully you can look at the, okay. Graph of inverse cotangent. Tangent x, is it really the tangent x flipped over? Oh, they didn't. Oh, wow. Did I put inverse? Okay, I'm going to use that later. If I graph 1 over tangent. If I do this, I'm going to hide this thing. This is not really tangent x flipped over. There's a phase shift because the location of your vertical asymptotes tell you. It used to be at pi over 2 plus k pi. Now it's at 0, pi, 2 pi, negative 2 pi. You get it? So the location of vertical asymptote is just at k pi. You know what I'm saying? Okay, now we flip this over. Then, wow, then of course it's reasonable to just, no. Like, do you want like all positive or all negative? Which way is it now, right? Oh yeah, we are back to that. See, since we gave the all positive to inverse cosine, why don't we make it fair and then for inverse cotangent, we'll take all negative, right? No. Those everybody wanted the positive, so we have to take this piece. Like, I'm not happy about it at all, but hey, I'll go with it. It's been decided already. So let's take that one, and then we'll put it here. Okay, so let's talk about this. This function, inverse cotangent of x, the domain is still everything, infinity to infinity. Your range is, now you have to be careful, 0 excluded to pi, eh? 0 to pi right here. Good. If you're gonna memorize the picture, not these useless things. Okay, so that thingy means like here, right? Quadrant 1 and quadrant 2. So far with me? In order to, I'll just do secant and I'll really show you from the notes. Because secant, see, I'm gonna hide this first. This is the graph of secant. right? It's like hangs on top of cosine. Cosine is right there in between. And then we rotate this over. Then it becomes this. I'm going to put this against the graph of inverse cosine. You see that this makes sense that we should cut it at exactly the same place. Because if you take this one middle piece, that still is not a function. You know what I'm saying? Still fails the vertical line test. So what we have to do is we cut this up, and this should be the graph, well, restriction of the inverse secant. You get it? Okay. In order to conserve time, we'll just go to this. So here is these graphs basically summarizes everything you need to know. Okay, this is inverse secant in red. I color coded this as well. I don't know how I pulled this off and making all of this in 1 hour, but I managed it. But then I used to be young and brilliant and really amazing back then, and now I got old and dumber, so I can't do it. Right? So domain and range that you learned last year, and still quadrant 1, 2. Likewise, inverse sine, you just hang it on top of this. You get it? That clarifies everything. Okay, then couple of things that we have to talk about is this. Time. Oh yeah, we got time. Okay, what about this question? Inverse sine of pi over 6. What is it? Pi over 6, of course, right? What about inverse sine of 7 pi over 6? Is it 7 pi over 6? Somebody tell me the answer. Oh, come on. You have to think about this. No. Somebody brilliant, make an impression.
It's negative pi over 6.
Thank you. Who are you? Identify yourself.
I'm Benjamin.
Benjamin, good for you. Benji. Can I call you Benji?
Okay, that's fine.
Benny?
I don't really mind.
When a teacher puts you on a spot like that, how do you say no to that, right? It's okay.
Yeah, I guess so.
Benjamin it is. You mean the inverse functions don't cancel each other? Well, if it's in quadrant 1, they cancel each other, and if it's not in quadrant 1, then there's no if then, case 1, case 2. This ain't chemistry. Math does not work like that. If there's a rule, there's a rule. Otherwise, it's not a rule. You know what I'm saying? It's like, forget it. Forget this, okay? And I'm gonna tell you a shocker. Inverse functions never cancel. Yes, you heard it, and this is on the recording. I repeat, inverse functions never cancel. What? You've been lied to all your life? Okay, well, I just want to show you something. Do you see it? E to the ln x. They're inverse functions. Can your young eyes see this function? E to the ln x. They're inverse functions, right? Actually, I'm going to blow it up. You know what I'm saying? E to the, it's the same size. So my question is this. If you have e to the ln x, does it give you x? What do you say? Why don't we graph this and find out, right? See, certainly they don't cancel. Domain restriction problem. Because ln only takes positive numbers, so it truncates the negative side, and you put e back, that positive, you're not gonna get that negative numbers back. You know what I'm saying? So as you can clearly see in this example, inverse functions don't cancel, especially when you restrict it. So why would that, these things are all under restriction, so why would they cancel? You know what I'm saying? Answer to this, by the way, is equal to x, and x has to be strictly positive because ln just truncates the 0 and negative side. Inverse functions only appear to cancel, but they don't really cancel. You get it? So we should treat it. If you put this into a calculator or computer will still do two-step operation. They don't know how to cancel functions. So this is how we are going to think. Inverse sine of 1/2, right? And then you evaluate that. That is, of course, pi over 6. So they appear to cancel this time. But this one is inverse sine of negative 1/2, correct? And then you figure out what that is, and that's negative pi over 6. These are always two-step operations, regardless of whether this is in first quadrant or not. Forget it. Inverse functions don't cancel. How about that? Most inverse functions appear to cancel, but you're still computing. You're still doing two different operations, and you get the original number back most of the time. But not necessarily, as you can see, especially when there's a restriction around. You get it? Okay, that's one thing. Okay. What about this thing? I think you have seen this, right? I'm gonna start with secant. Inverse secant of x, is it equal to 1 over, what do you say? Because we know, after all, secant x is, by definition, this, right? So does it really apply to this? No, it does not. When you say inverse something, inverse cosine, inverse secant, this means it's an angle. You know what I'm saying? So if this is pi over 6, 6 over pi, there's no relationship between the two. Are you kidding? So no, God, no. So what is the correct relationship? Maybe some of you memorize this, right? Remember this? Or remember forgetting this? What? How do you? Okay, let's figure that one out. We'll let y to be inverse secant of x, okay? That really means is secant y is equal to x with all that restrictions, right? Quadrant 1 and 2. Let's try to draw that triangle. And then, of course, your idiot pre-calc book drew it like this, right? Okay, Larson, for the record, I want you to know that I think you're an idiot. Now I have a question. Can x be negative? Can this x be negative? Yeah, we talked about domain and range, right? It stretches all the way to negative infinity. What happens if this x becomes negative in the diagram? It ends up here, right? But then nothing ever exists in third quadrant, our restriction problem. You see the problem with that? So no, it doesn't exist there. It's supposed to exist in quadrant 1 and quadrant 2. How do you make this thing go to that side? Well, unless you are very, so this is a correct way of doing it. See, if you take y is the angle, remember, if you take secant of y is this side over this side, which gives you x. You know what I'm saying? However, let's say if you take cosine of y, does that give you 1 over x, right? Cosine is this side over that side. And if x becomes negative, then it extends to this side now, doesn't it? See, x is negative. See, it makes sense? Negative x value here. So this is still quadrant 1 and 2, and it can stretch out all the way to negative infinity, but x, you see, has to be more than 1, right? So it actually fits our domain, which is negative infinity to 1, negative 1, union 1 to infinity. You know what I'm saying? Because if x is less than 1, then the hypotenuse is longer than hypotenuse. There's a problem with that. Now, finally, we will write it in terms of y. That is inverse cosine of 1 over y. And what was y? Let's compare this line with that line. They are the same y. So we can equate it. Therefore, we can say inverse secant of x is equal to inverse cosine of 1 over x. That identity comes about. Amazing, isn't it, huh? You don't need to memorize anything. The logic, the truth will set you free. Only thing I care is that you know where these things come from. Any questions? Okay, I'm gonna stop the video right there.